And around those suns, are there other planets? And on those other worlds, are there beings who wonder as we do? Here is a light bulb, which is supposed to represent a nearby star. And next to it, and very hard to see because of the bright light, is a planet. Now we'll need a volunteer who would like to come up with these. Ordinarily, you would have a hard time seeing the planet because it's so close that the star washes out the planet. But if we were able to put something in front of the star to make an artificial eclipse, then we might be able to see the planet. So I'm going to stand over here. Imagine that I'm a telescope somewhere near the Earth. And Tab, if you'd slowly move the disk across. Good. A little faster would be nice. Good. Now you're just beginning to cover over the star. I really can't see the planet at all. Keep going. Good. Now right there, I can't see the star at all, and I see the planet lit by the light of the star. Now that is a method for looking for planets around nearby stars. And that method uses a spacecraft to hold the disk and scan the sky for another telescope to see if there are any planets. So, Tab, you have successfully accomplished your mission to look for planets around other stars. Thank you for being our interplanetary spacecraft. So, this is one way. And there are spaceships that will be able to do this in the next 10 years or so. And there's another way. This has already been tried from the Earth. Imagine that there's a nearby star that you can see. It's bright. And it has a dark companion, a planet, shining only by reflected light near it, so dim you can't see it. But imagine that this planet and its star are going around each other, like that. You can see the star, you can't see the planet. So now I'm going to need 2 volunteers. One, you two. Because, just to save some time, because they're... Now, I need one of you to turn the star and the planet, and another person to pull the star and planet along. And what you will see is that the star you can make out will be moving in a funny, wiggly pattern, which will be the clue, the evidence for the existence of the dark planet. Okay, let's have a spin. Good. And a pull. And you see this funny motion that the star makes because of the planet. Thank you very much. So that's another way of finding out the existence of a planet that you couldn't see directly. Well, both of these methods are being used. And by the time that you people are as old as I am, we should know for all the nearest stars whether they have planets going around them or not. We might know dozens or even hundreds of other planetary systems and see if they're like our own or very different or no other planets going around other stars at all. That will happen in your lifetime. And it'll be the first time in the history of the world that anybody found out really if there are planets around the other stars. Now, the nearby stars, the ones you can see with the naked eye, those are all in what's called the solar neighborhood. That's really what astronomers call it, the neighborhood. But it's a very tiny place in the Milky Way galaxy. The Milky Way is that band of light that you see across the sky on a clear night. I can't tell if there are any more clear nights in Brooklyn, but you must have seen the Milky Way, right? See, faint band of light at night. Well, that's just 100 billion stars, all seen together, edge on, as in this picture. If you could get out of the Milky Way galaxy and look down on it, it would look like that picture. And if we did look down on the Milky Way galaxy, where would the sun and nearby stars be? Would it be in the center where things look important or at least well lit? No. We would be way out here in the suburbs, in the countryside of the galaxy. We're not in any important place. All the stars you could see would be in a little place like that. And the Milky Way would be this band of light, 100 billion stars all together. The fact that we live in the outskirts of the galaxy was discovered long time ago, towards the end of the First World War, by a man named Harlow Shapley, who was mapping the position of these clusters of stars. See, every one of these is a bunch of maybe 10,000 stars all together. It's called a globular cluster. And you can see that they are centered around the middle, the center of the galaxy. People used to think that the sun was at the center of the galaxy, something important about our position. It turns out to be wrong. We live in the outskirts. The globular clusters are centered around the marvelous middle of the Milky Way galaxy. And then it turned out that this isn't the only galaxy. We live in this one, but there are many others. And as this picture reminds us, there are many different kinds of galaxies, of which ours might be just this one. There are, in fact, 100 billion other galaxies, each of which contains something like 100 billion stars. Think of how many stars and planets and kinds of life there may be in this vast and awesome universe. As long as there have been humans, we have searched for our place in the cosmos. Where are we? Who are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people. We make our world significant by the courage of our questions and by the depth of our answers. We embarked on our journey to the stars with a question first framed in the childhood of our species, and in each generation asked anew with undiminished wonder, what are the stars? Exploration is in our nature. We began as wanderers, and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean. We are ready at last to set sail for the stars.